Welcome to the Contagious Code podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I am Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, my guests are Daniel Ehrenberg and Kristen Maevyn from TC39, the committee that creates the JavaScript programming language. In our discussion today, we dive deep on the signals proposal and talk about fine-grained reactivity. In our discussion, we contrast reactivity with observability and go very, very deep on signals, not as a primitive in like Solid.js or some framework, but as a language feature. Given that signals is being proposed as a language feature to the JavaScript programming language, what this means is that we get a very powerful primitive for reactivity in the language that works in every runtime where the language runs, including browsers, but also server-side with Node.js. And we explore what it might look like to have signals, that is, these reactive primitives, on the server side and on the client side, and enable some type of interactive handoff between them. For those who aren't familiar with signals, this is the episode for you. For those who aren't as familiar with JavaScript or how the language is made, this is also the episode for you. The TLDR is that signals are reactive values that notify subscribers when they change. Of course, in the episode, we go into way more detail, but that should sort of whet your appetite for the discussion. Now, I'd like to offer this to all of you at no cost because this is very separate to my day job. And the way we can do that is through partners and sponsors. Let's take a moment to acknowledge them. The Contagious Code podcast is partnered with Code Crafters. Code Crafters teaches people how to code in a way that I do. What they do is they have you choose a programming language like Python or JavaScript or TypeScript, and choose a tool that developers use like Redis or Docker or Postgres. And they have you build the tool from scratch in the language that you choose. And by doing that, you get better at the language and also understand the tool deeper. And you ultimately level up as a developer. They have a generous free tier, but if you want to start paying, you can get up to 40% off using the link in the show notes. That's tej.as/codecrafters. The Contagious Code podcast is also partnered with React Africa, a conference happening in Casablanca, Morocco. We're giving away up to one free ticket. If you'd like to win, share this episode on social media, say you'd like to win, and we'd get you a ticket, or you'll enter a raffle to do so. We also encourage you to attend this conference where I will be giving the opening keynote. Thank you so much for sticking around. Now for my discussion with TC39's Daniel Ehrenberg and Kristen Maevyn. Hey, Kristen, Daniel, thanks so much for coming to the podcast. Welcome.
Hey. It's great to be here. Thanks for inviting us.
I'm so excited. This TC39 episode has been a long time in the making, and we have so much ground to cover. JavaScript is changing, and this is the committee that helps drive that change, that indeed drives that change. So we've got a long list of things to discuss. In fact, the audience has also chimed in, and so I suggest let's just dive right into it. Let's start by talking about reactivity. What is reactivity, and why is it being considered as a language level feature?
Kristen, why don't you answer this?
Reactivity is a really hard thing to kind of pin down, but this is really a problem that's gone back a very long time in programming history. I remember going back to like the original kind of functional reactive programming white papers and trying to understand like what they were dealing with. It's really like, how do things change over time? And how do you react to those changes and update the state of your application, the thing that you're rendering to the user? And how do you do that in a way that's like very consistent, right? One of the goals of a lot of modern rendering frameworks is that you have this sort of from scratch consistency where if you get into a certain state and then let's say you reload, the application, you end up in that same state with things looking generally the same. So like one thing with single page apps is you navigate to a certain URL and you might be doing that, without any actual page loads, but if you hit Command R, right, you end up on that same URL. But it kind of goes like deeper than that. It's more about being able to reproduce any state from or any view, any like rendered output from a given state, from a given input. And then being able to do the deltas, the changes between those things in real time.
Yeah, I see it similarly, I mean, one way that I think about it is like the view is a function of the model, to use the kind of outdated MVC terms that aren't cool anymore, or whatever's on the screen is a pure function of the data. So like a lot of these concepts that React really popularized are a good frame for understanding this. For it's just what the HTML that you see should be just based on the state and not based on what happened before in the program. So then the reactivity system, which for us is signals, that's the one we're developing, is supposed to efficiently implement that. But it's like more efficiently calculating how could I do this minimal recalculation to make it so that it's as if we started from scratch and are calculating the whole function.
Interesting. So, Kristen, you mentioned that reactive systems are important because of how data changes over time and keeping applications deterministic in response to how data changes over time. There's been attempts at solving this, right? In sort of library land, things like Redux or RxJS specifically will work with like reactive state to give you a final rendered output. We have you mentioned signals from SolidJS also, not from SolidJS. You mentioned signals in general, but I feel like that's sort of the flagship implementation. Why is this now making it into the language level scope from just being the library scope?
Yeah, I would say one of the biggest motivating factors is compatibility. Um, this is kind of similar to like when promises were added to the language, right? There were a lot of libraries that were kind of making venables, promises in various forms. Um, but you needed to be able to coordinate between a whole bunch of libraries, a whole bunch of packages. Um, and I think it's really interesting because we have all these different frameworks like Svelte, Vue, Ember, Angular, that were all kind of independently coming to the solution that we realized was very similar across the board. Like everybody kind of
Interesting.
independently created their own implementations of signals over time. Um, and then we started thinking like, okay, it would be really useful if we could have kind of deeper integration, not just in the rendering layers, but all the way into like the data layers, right? It would be really nice. Like Apollo, for instance, Apollo client is actually based on observables. It's based on kind of RxJS style reactivity. So if you plug that into a rendering layer that's built on observables, um, everything just kind of works out of the box. You don't need to write like an in-between layer that translates between the two. Um, there's also, of course, like the idea of like interoperability between frameworks. Maybe you write some components in web components, and it would be really nice if you could just use, a Svelte component in your Vue app, or, just if you didn't have to worry as much about like what framework a particular
Yeah.
component was written in.
Or
Um, yeah.
something being a child of something else is maybe especially hard, but if you have two things that are kind of siblings or like different islands on the same page, they could have the same model. And as long as they're both based on signals, then they should interact in this completely consistent way. I think it would be really great if we get to this like rendering unification, but that's this whole other kind of project also, right? Uh, but yeah, I think like you're saying, having the data layer being reusable is great because this is about separating out the model from the view, being able to have different presentations of the same kind of data and having that those be kind of maintainable separately, and yeah, having the standard interface between them being signals.
I love this. This seems to track with how standards bodies just work in general, right? Like you leave userland to do what userland does, and at some point there's a convergence. Like you mentioned, I love this parallel you drew, Kristen, with promises, and now signals, because there was Bluebird, there were all these different tools, and JavaScript was like, okay, we're gonna have it be part of the language. I love that, and I think that's so interesting to see where it goes, because you can then do what you described, have data-driven signals that also work with any front-end implementation because it's part of the language. Absolutely cool. So you just go up one level of specialization, essentially. We've mentioned signals a few times. Let's maybe take this opportunity to talk about them. What are signals? How are they different from observables and other things most listeners would be used to? And why did the TC39 choose to move forward with this specific reactive primitive?
Yeah, so signals are kind of a different take on reactivity compared to observables. Observables are push-based. So every single time something changes, you send an event through the system, and then it kind of activates everything. This works really well for like very data-oriented systems, kind of back-end systems sometimes, right? Where you want to have this constant stream of events, and you probably want to capture all of them and process all of them. But it doesn't work as well for a UI-driven system where you don't really want to react to every single change. You want to, it's more like you want to react to every single change every time you render, right? You're limited by the frames per second of your application, and oftentimes more resources. Like you don't want to be rendering every single frame per second, or every single like request animation frame or whatever. So that is kind of more one of the reasons why like signals end up being better for UI driven stuff, front end applications and whatnot. Another key difference I would say is that with observables, you kind of end up in the abstractions of observables writing a lot of very specific code that is very, it's like almost a separate language, like a language on top of the language, where you have like these pipe operators, these various like transforms, and it gets very complicated, and you kind of have to have a lot of context. Signals are, especially auto tracking based signals, which is what we are proposing. They are more like standard function calls. In fact, I kind of see them just as like inverse memoized functions. So when you call a signal, a computed signal, it runs, it tracks whatever values, reactive values it uses, and then it only reruns if those values change. Otherwise, it just returns the cached value the next time you call it. And that is, really, it kind of gets to this notion of like what we've recently been calling signal peer. It's like very similar to functional programming, except for you can reference values in the global scope or in like, maybe a local scope, but not just the parameters to your function. You can even track like changes deeply on objects, nested on objects and in arrays and whatnot, without having to like worry about, oh, did that get cloned? Do I have to do a deep comparison? You don't. So that makes it, yeah.
Yeah, and one of the things that's different from, because of auto tracking, like Kristen was saying, that's different from observables is that you don't have to unsubscribe explicitly from signals. Auto tracking just keeps it always the correct set of dependencies. So to back up briefly, there are two types of signals. There are state signals and computed signals. State signals are like a cell of data that you can read from or write to, and computed signals are a function over whatever you want. So a computed signal takes a callback, and it can do whatever calculation if it wants. If in that callback it happens to read another signal, whether a state signal or a computed signal, it registers a dependency. So then there's a third thing called an effect, where you can have a callback that gets run when the thing in that callback changes. So when you make an effect, it runs it once immediately, and then it records the dependencies. And then if any of the state or computed signals changes, then it reruns. It schedules a rerun at some point. So putting those three things together, it ends up being kind of similar across all kinds of frameworks. They all have mechanisms that are like these. They have different names, but we chose those two names, state and computed, because they were kind of the rough consensus, and signal was kind of the rough consensus name for the concept overall. And yeah, just to stand in for this pure computation graph. And one thing
Okay.
last thing about computed signals is they're memoized, so they remember the last value. So if nothing changes, then when you access it, it just returns the same value. And
The same memory address.
yeah, the same memory address. It's all by reference because we're JavaScript,
Yeah.
and it's also lazy. The computed signal doesn't get calculated until you access it. So that's what differentiates it from observables, because observables being push based, laziness is the same as being pull based. But it's similar to observables. Signals are similar in the sense they're both synchronous. When you get something, those lazy computations are done immediately, right when you calculate it. It doesn't add this asynchrony the way that promises do.
I want to double click on many, many things you said here, mainly because and a lot of the listeners probably would not have registered many of the things you said. So I want to dive a little bit deeper and ask for clarifications. A lot of, sometimes listeners listen to this and they tell me in private, they're like, you asked questions that I was afraid to ask. And so I wear that as a badge of honor. So with the comparison with observability and signals, both of you mentioned that observables are push based, meaning, Kristen, you said they change and then they trigger a cascade of code of execution. How are signals pull based in contrast? This is what I don't understand. So, it seems like so you talk about a computed signal, and by the way, Dan, I love the distinction between state and computed signals. That is so cool. So, if I have a computed signal that depends on some value, then when that value changes, does it not, in a push-based fashion, update my computed signal, and thereby being close to observables, as we talked about? I don't see the difference between push and pull as clearly here.
Yeah. So the way to think about it is kind of more like a memoized function here as well. When you update a value that you pass into a memoized function, the first time the code of that function runs is going to be when you called it, right? And when I say memoized, I don't necessarily mean like React use memo. I mean any kind of
Actually
memoized. I mean, so it's whenever you actually call that function. It's the same thing with computeds. Rather than immediately rerunning the function and updating the value, we wait until the user has asked for the value. And they'll ask for that by calling, I believe the API right now is signal.get, and you'll do that on a computed signal. That is when we actually run the user's code. Now, behind the scenes, when you update the value, it does potentially trigger a more push-like mechanism. There's actually several different algorithms that work in different ways. Some are fully pull-based. Some are kind of a hybrid. I don't think that it's super important which one you're using. We could describe the one we're using right now. I'm working on maybe a slightly more efficient one. It doesn't really matter though, because that's not the high-level API. The high-level API is your code, the code that you define in a computed, does not rerun until you ask for that value.
Awesome. Thank you. That was so perfectly stated. I fully understand it now. So, okay, this makes a lot of sense. And you know why I was confused? Because of Solid.js, which is it sounds controversial, but the way Solid.js works is when you update, which y'all are aware of, but just for the listeners, when you update a value, a state value, and there's a signal that uses it, the signal updates. But I guess the part that I didn't realize was I'm implicitly asking for the value by rendering it in the UI.
Right.
Yeah.
And that's what you mentioned, Kristen. It changes when you ask for it in a lazy way, but I always ask for it. So it seems to be a push-based mechanism, but it's not. That was so cool.
Exactly. It's more that, and I guess this is kind of the last component beyond state signals and computed signals, It's that something is constantly asking for that. And in our case, the API that is currently in the proposal, that is a watcher. And watchers kind of represent something like the DOM, or the rendered application. Could be like a separate process if you're on the server or something, right? It's just something that's sitting there, kind of actively asking for that thing continuously. Um, so as long as it's in the DOM, that thing will continue to ask for the next value and keep keep that going. However, once you remove it from the graph, we're no longer pushing to it anymore. We're no longer like pulling that value through. So that code no longer reruns. And that is, however, it could rerun if like you ask for it in a event handler. Um,
Right.
it could still be around. It just might not be live, right? It might not be connected to any output at a given moment. And so we might just be waiting until the next time you ask for it.
Yeah. So when we talk about the push and pull, the push that's happening, because it's not going to actually run the callback until you ask for it. But what it can push is an invalidation signal. You there Whether you pull the invalidation or whether you push it, somehow the system has a way of knowing in advance which things might have changed. And so this is what watchers can do. So what Solid does when you reference a signal in your JSX, it creates an effect. If you look at Solid's JSX transform, the effect
Yes.
is right there in the if you have something that uses HTML directly. So it adds this effect that reads the signal, and the effect, if you were going to implement it in terms of our signals proposal, it creates this extra computed signal that it adds to a watcher. And so the contents of that are rerun if one of the things in the expression in the JSX changes. And so the watcher gets this notification that gets pushed to it when the invalidation occurs.
Awesome. I understand this so much better now. You alluded a few times, both of you did, to the API. I haven't looked at the proposed API, mainly because it's in a proposal stage, so I'm assuming it's going to change over time. So I don't want to invest too much into it. And the same caveat for the listeners, like what we're about to discuss, is probably will change because it's a proposal. That's what proposals do. But if I was to use this today, would I instantiate this with new? Is that how it works? Like, would I do like new state signal and then give it an initialized value? Or is there more to it?
So I believe the current API is there's a global called signal, and then you could do new signal.state, which is the state class. There's new signal.computed, and yeah, that would just work, quote unquote. I don't know if the polyfill forces you to import those. I think it does, so it doesn't actually patch the global. Best practice there in general. And then in order to, you could just use the states and computeds on their own. And that would effectively just be like using a at memo decorator on your, like a function or something, right? Like, or a method. You could just use those as a way to efficiently check when a particular value, computed value needs to update. But if you wanted to hook it up to an API, or rather a UI, a rendering layer, you would probably also then add a watcher. The watcher would kind of represent that effect, like Daniel was saying, and then that would you would feed those computeds into that.
Yeah. Okay.
We,
That's
we know that we know that new is really ugly, and we actually don't want people to really be writing new signal.computed all the time. We focused on having the right underlying semantics, getting the graph algorithms correct, getting it so that we could have a unified auto tracking mechanism that everybody could actually use. And the idea is that all the different frameworks will wrap this signal primitive, and they'll share their ergonomics. So that's what people can use on top. And we actually have a library that we're developing, which is available at um, GitHub signal-proposal/signal-utils, which is a bunch of abstractions on top of the core signals, where then you don't have to use new signal.computed anymore. You get these reactive objects or different kinds of store abstractions. I think it's really important that people think carefully about how they organize their state, especially. Computeds, you can be more sloppy about because they're just sort of a cache, and they're invalidated correctly by the signal mechanism. But the state, you want to think carefully about how to organize that.
Yeah, I think just to add on to what Dan was saying there, the um, new like this API in particular, I'd say, is kind of more targeting like what is more natural for JavaScript as a language, what makes sense for JavaScript as a language, which does have newables, classes, whatnot, pretty frequently. And also, like we were thinking about this in terms of being able to implement things like um, subclasses and being able to kind of extend these signals a little bit in a very JavaScript-like way. But yeah, wrapping these is definitely something that we think is going to happen. And if you want like better DX, better ergonomics, I think that is perfectly, that's one of the benefits of having a unified proposal. It's like it won't matter how you use it necessarily. You can have all the utilities in the world. Um, Everybody that uses signals on the other end will still be able to consume them.
So you just mentioned better DX and better ergonomics without the use of the new keyword. So it seems like both of you like sort of accept that new is just not ideal. But at the same time,
Yeah,
It's out of fashion.
it's out of fashion. I personally don't hate it. I think it depends on what your goals are. In a very strict sense, I think that new exposes a wider API surface. So you got to be really comfortable with exposing that class and the details of that. In this case, because we're trying to expose subclassing and the ability to do that, that makes sense. But in my own libraries, I am more cautious when I expose a newable. I but I also don't avoid it just because I think it's like worst EX myself. It's just like a lot of people seem to think it is, and that's fair.
why? Why is that? Even Daniel, you just said it's out of fashion. Where does this come from, this hatred
Well,
for new?
I completely agree with what Kristen said about how new exposes this kind of detail of your structure. So in particular, it's somehow more encapsulated to have a factory function that you export, because then you could have multiple different functions and you don't have to have one privileged constructor. I mean, that argument about it being weird that the constructor is privileged goes back to the beginning of object-oriented programming in general, and it's why some languages, I think, does Objective-C have where you just have static methods for this, or maybe I'm making that up. The thing is that once you have abstractions on top of signal.state, then they can be more opinionated. And the other thing is about subclassing signal.state and signal.computed. We developed the API shape based on a lot of discussions among framework maintainers and certain amount of experimentation. And that led to the idea that certain frameworks might wrap signals, might have another object that wraps it, but some of them might actually really want to avoid the extra allocation that that wrapping entails. So if you subclass, that gives you an extra place to put a field. And we made sure that public and private fields both can be added to subclasses when we designed private fields in JavaScript. So that's a tool that it's just a tool that implementers of frameworks can use.
It this may be a bit of a sidetrack, but now that we're talking about the new keyword in classes, we have to talk about this because the listeners would want us to, right? And I think you know where I'm going. That JavaScript seems to be very divided, and people just don't like classes for the most part. At least from the more like React programmers, like the people who think everything should be a function. It's not just that I understand classes. There's a time and a place. For example, if you want to have a more extensible API service, or if you want to have subclassing, etc. Like the discourse is not yes, it's available. There's a time and a place for it. It's more no, this is bad. We should never use it. Why? And also, can we maybe capture some of the nuance there, specifically around what classes are good for in JavaScript and what they're not, and why the language
Yeah.
even has them. I mean, it's kind of obvious why it has them, but y'all make the language, so I think me and a lot of others would be very interested to hear your what you have to add to that.
Well, Kristen and I worked together a lot on classes on making decorators happen, and decorators are just a feature for classes. Uh, Thanks to
At the
Kristen's,
moment.
yeah, at the moment. I hope we get function decorators, and I don't know. I'm a crazy person who thinks that local variable decorators would also be a good idea, but that doesn't have consensus. But classes are a really good way to group state and behavior. And that's something that if you ever have a function-based component with useState in it, you're kind of doing a class-like thing. And that was a lot of what was behind our vision with decorators in the first place. That you want classes to be programmable for them to reach their actual potential with how you can group these things. And anyway, I think the important thing is that you have, for example, when you have a store, then you can at least define the state and behavior somewhere together, which could be with object literals or it could be with classes. They can both work.
And for exactly reasons I don't know, for example, Redux, I've seen a lot of these talks where people will be like, let's implement Redux from scratch in 10 minutes. They always create a function called create store that returns an object literal. And I'm like, this looks like a class. Why not use a class?
So I think this is maybe like more just my opinion. I wouldn't necessarily say any of this is like fact or anything, but I think a lot of it is functional programming, maybe taken to an extreme, or the ideas of functional programming, and this idea that if we don't use classes, it's somehow not object oriented. I think, like Dan pointed out, um, like if you are using use state in a function, if you are using scoped variables in functions, I've seen a lot of code that ultimately ends up working a lot like a class, even if it is not technically a class. Um,
Exactly.
but I do think that there is kind of this push toward that. And I think that started, like, the thread there started way back where we were really realizing, like, we had gone deep and deep and deep since the 90s on object oriented programming in the computer science world. So the swing towards functional programming was not unreasonable. Like, I remember when you had to, use for loops for things like, array.map. Um, in a lot of cases, there were a lot of places where imperative code was like the only way to do a lot of things.
Yeah.
Um, so not only that, there has been a very uh long history of academics kind of pointing out like, hey, functional programming languages actually have a lot of really cool guarantees and safety, and they kind of eliminate all of these types of problems. If you just write things as pure functions, you don't have to deal with all of these issues that you can run into. And on some level, that's true. You know, like if everything really is a pure function, like all the way down, you do have a lot of nice guarantees. I think there's a lot of caveats there. Like, I do not think that most modern frameworks, that like JSX based frameworks, JavaScript frameworks in general, really enable that. I think if you look at something like Elm, that has a lot of those guarantees. But then you're going deep into learning a fully functional thing. You're adding a ton of restrictions, which are maybe beneficial. If you look at something like React Reason, where again you're using OCaml or whatever it is, that also does the same thing. When you're using JavaScript, the state sneaks in there.
Yeah.
I'm currently working on like a layer on top of React Router, so I'm reading a lot of React Router code. There's a lot of object-oriented-ish code in there,
Yeah.
a lot of state. I'm going through a lot of our code base at Phantom, and there's a lot of state and object-oriented kind of code, and I think it's just part of the language. That said, I think modern languages are learning from this. So I, at my last company, wrote a decent amount of Rust. And Rust structs are like some of the best parts of JavaScript classes or just object-oriented programming in general without a lot of the worst parts. Um, it's kind of like a stripped back version that's more similar to like C structs or whatever, but better also and way more type safe and whatnot. So I think yeah, there's a balance that can be achieved here. I think there's benefits to it. Um, and in terms of like why do we have them in JavaScript? It's unfortunately JavaScript does not do breaking changes, or fortunately, like there's a lot of benefits to that. Um, but we can't change the four core fundamentals of the language at this point. So object oriented stuff is there. It's been there with prototypes. Classes simplified that. If you remember writing prototypes before the class syntax, it was a nightmare. And I think moving forward, we can work to make classes better, and we can work to make reactive programming better. Like part of the reason I think that React programs end up getting so complex and having all this state is because functional programming is great until you need to deal with state changes. And like
Exactly.
React and all of these other frameworks have dealt with that with VDOM, but that doesn't scale. Like you can't do that for the entire program. And then that's where the complexity starts to sneak in. That's where you need like, oh, use state, use effect, use layout effect, like use all these little things. So I think signals, bringing it back to that, really are like a way to get some of those benefits of functional programming, but to do it in a way that is more, that works better with JavaScript and also potentially handles some of the things that we've been struggling with functional reactive programming since the beginning of functional reactive programming.
Yeah, I totally agree. So in particular, when you're doing UI development, how can you blame programmers for wanting to have state? Like they're trying to make a screen where you click through different steps or you fill things in and then something happens. You know, things are happening. So how can that not be represented by some kind of state? I think the
Yeah.
challenge is to keep the state normalized in the database sense. You don't want to have multiple copies that are all kind of all authoritative. So if you want something that's kind of a function of something else, something that's based on something else, you want to make sure that that based on relationship is actually represented. And this is what signals let you do with computeds. So there's actually an identical anti-pattern that you have with React and with signals. So with React, you can have a use state and then you could have a use effect that does some calculation based on that state and then writes into a different state. And you're really you really shouldn't do this. You should just make a use memo and it will do the same thing except with better timing and with a lot of errors removed. And you can do exactly the same thing with signals. With signals, you can make a state, and then you can make another state and make an effect that, you know, updates one when the other changes. And this is exactly the thing that, regardless of whether you use React or signals, you need to watch out for. You need to make sure that you have an authoritative place where your state lives, and then you have other things that are kind of non-imperatively, non-destructively based on it, that are just using it and referring to the right original thing. So somehow this real state is like the irreducible part, and then then you get this extra state that ends up creeping in due to um, various things. Like many situations are not as trivial as the use state with a use effect pair, and you end up kind of reproducing the same pattern. And that's, I think, what we're trying to get at with encouraging these sort of functional structures, whether with signals or with React.
Incredible. Thank you both. That was such a useful and thoughtful discussion. It's what I'm hearing is signals are an evolution of a long-standing problem in the way we use JavaScript to create applications. And the problem was the problems with classes were that they almost contain too much. state to the point where you break you can't encapsulate effectively enough, and then with functions the pendulum swung the other way. But you still need state. Like if like you said, Daniel, like if you have a any user interface or not any like command line interface, any interface in general, it's an interface. And by virtue of being an interface to a human being, there's going to be state. There's going to be text input. There's going to be something. And so the evolution was okay, functions are they have benefits, as you mentioned, Kristen, right? They can be encapsulated, they can be tested in isolation, etc. But they can't be fully pure because they have state. And so you have this weird place of React where it's like it's a function, but it's not pure because you're calling out to use state, and use state is updating some global scope dependency array. And so the solution, so signals lands here in this space as an attempt to actually bring the best parts of both together. How accurate is that to where we are today so far?
Yeah, I think that's pretty accurate.
Yes.
I think to add on to your description about like the extremes, the way to extreme object-oriented programming, I would say, is like Java, where you cannot have a function on its own, right? It's like you have
Yeah.
to have static functions for any like basic utility function in Java, which is kind of crazy if you think about it. JavaScript has this really nice mix of like you can have a function, you can have a class. If a class makes more sense, do that. If a function makes more sense, do that.
Yeah.
So yeah, I think that is accurate. Um, yeah, signals. I think the only thing I'd say beyond that is like this is like a problem that stems beyond just like that state in JavaScript itself, like dealing with these reactive problems in JavaScript itself. Um, like I think even in academia, they haven't really had like super like they really love historically functional languages, but they haven't had great solutions for like reactivity in functional languages. It's usually something more like Elm, where effectively, I've only written a little bit of Elm, but as I understand it, it's like kind of formalized Redux. Like all of the state is externalized, and anytime something changes, you are basically rerunning the entire program, basically because you know do DOM diffing, skip the parts that don't need to change, et cetera, et cetera. But like that, I think that strategy doesn't scale from a like programmer perspective. Like it doesn't tend to work really well to isolate parts and work on them independently. And also, it doesn't really scale from a performance perspective at a certain point.
Yeah, we have a sort of pendulum swinging back and forth thing going on with state management. Like, I don't know, 10 or 8 years ago, we were all convinced that we should be doing Redux for global scoped state. And that has a lot of benefits. I mean, Kristen mentioned before, like routing. The route has to be a global piece of state. Some pieces
Yeah.
of state are just logically global. And now with React hooks, we have this idea like, let's just use state for everything and just like make the state where you need it. Uh, and this goes depending on how you use it, because there are a million ways to use these things. That could kind of mean that you're it could be that you put it in the place where the state logically comes from and goes to, but often that place is like somewhat higher up in the tree, maybe not totally global. It may be somewhere in the middle where the state should be. So I think things like zoostand are kind of the way forward, where it's pretty lightweight to make a store. It doesn't have to be like a huge deal. You can group the state, but it doesn't have to be at the complete top level. So as we get deeper into exploring state management with signals, I kind of suspect that's where things will land, and people will just have to be thinking about where is the logically appropriate place to put my state. How do I group the things that should be grouped and not group the things that shouldn't be grouped? I mean, to be fair to Redux, I think RTK gets into this with slices, and they have some pretty good solutions. But uh, ultimately, with signals, the graph is all kind of disaggregated. The the dependencies go straight to their usages. You don't have to do the
Yeah.
thing of starting from the top of the tree, checking which things are equal, and redoing the things that derive from that, and then you end up cutting off the computations of the leaves, and like asymptotically, you're still cutting off most of it. But signals jump straight to the place where they're used.
I think that it's interesting that you bring up ZooStan because we've been having an internal discussion about like what we should use for external stores. We haven't like adopted signals yet. We don't. I don't think there's really a solution in the React ecosystem that is like mature enough for us to really go for it, even at like a library level.
You mean we
Uh,
like in Phantom?
huh? Yeah.
In your okay.
At Phantom. Um, I'm going to, I want to explore it, but it's just like at the moment we kind of, have a lot of other things to do, so it doesn't really make sense yet. But I think it's really interesting because one of the things I'm noticing that I really didn't struggle with at all in like Svelte or Ember or other languages that frameworks rather that I've worked with is this like constantly thinking about how a change is going to trickle down through the DOM or
Yeah.
the component tree and trigger re-renders, right? Because in those other frameworks, it was more like I would pass down a value, but that value would not get passed down if it didn't change, or if I passed down an object, that object would have signals on it. So if I read a value, that only then would it update. Basically, I could have like my root, main application component. I could define some state there, and I could prop drill that or use a context to send it all the way down to some leaf, 10 nodes down. And then I could read that in that component all the way down there. And if I changed that value, the root component would not re-render. None of those other components would re-render. We didn't even have to check any of them. The only thing that would re-render would be that child that used that piece of state. It's something that really helps in terms of that kind of like isolating that and understanding that and knowing like, okay, when I change this value, not everything is going to rerun, like not the entire component tree. I don't have to like think about all that. I don't have to like memorize that and make sure that like every object is like either not changing its reference or is like memoed properly or whatever. It's really really nice when you don't have to worry about that. And this job is the first one where I've written this much React, and I'm just like, oh man, as I implement a context, and I'm like, how am I going to do the change tracking here? It's really what it is, and I'm going to get a little bit like computer sciencey here. I'm going to use a word that maybe some people will get a little triggered about it.
Please do.
I definitely was a lot in the past. Monads. It is
I'm
really yeah, signals in a way are like monadic hooks. They are rather than, you know, it being this value that you kind of have to re-execute everything to understand the next time around. It captures the context of what is being reactive, and then if that context changes, it updates, and you can pass that value around just like you can with a promise. A promise is kind of another monad, right? You can pass it around, you can do .then on it in multiple places, it'll restore its context, it'll return its value to you the next time the program executes. Monads are kind of like, or sorry, not monads, signals are kind of like that, but for reactivity, where it's like, oh, this part of the program needs to rerun when a value that it depends on updates. So I'm going to do that. Versus with promises, it's like this part of the program needs to continue running when a value that is asynchronous comes back or some asynchronous process finishes, right?
I
Yeah.
want to
Um,
I want to ask a silly question here because I'm a little bit confused about this push and pull thing, because you just said, Kristen, there's a portion of your program that needs to rerun when this value changes. that sounds very push based. Sorry to keep coming back to this, but do I understand correctly that an alternative way to phrase this is you have this piece of software that needs to run when a user reads this signal. So not when something changes, but because it's lazy and pull based. Do I like what am I missing here?
The only part that you're missing is that watcher part, right? Like, so if we are talking about a program that is like a component based UI framework, right?
Sure.
You can look at the program as like it's a depth first walk. You're like executing all the functions, right? Through the
Yeah.
function stack. Like imagine your flame chart, execution
Sure.
chart in when you're doing performance debugging in JavaScript, right?
Yes.
You're going through it. And the like every function in that, every leaf node in that effectively represents some fragment of DOM, right? This was the thing
Hmm.
that React figured out that was brilliant. It's that you can basically just have your like output literally directly map onto a bunch of function calls, and the
Yeah.
execution tree is the output. Absolutely
Yeah.
brilliant. Um, what signals add on to that is okay, and now we're going to say that entire tree is active. We're going to watch it with a watcher. And then the portions of that tree, the components that need to rerun while they're being watched, they will rerun when the signals that encapsulate them or that they use are um, dirtied, are like some
Yeah.
dependency has changed. In the signal model, it's a tree of computeds,
Mm.
and those computeds consume those signals, consume that state, and that's kind of that. Those individual nodes are kind of those monads I'm talking about, where it's like, okay, this will rerun when that state um, updates.
Right.
Yeah.
Because
So
of the watcher.
yeah, so you can
Got it.
see assembling this watcher and assembling this tree of computeds is actually pretty complicated. This is why I really would recommend keep using a framework. As people use signals, that doesn't really mean that you can just use vanilla JS for everything. It is pretty confusing. So that we're biting off a chunk of the problem, but we're not solving the whole problem of reactive tree rendering. I would love it if we could come back and do that, maybe in web components land, but yeah, we don't. If we bite off too many things, we might get something that's not usable. So that's why we're first
Yeah.
focusing on something that's embeddable inside of frameworks.
Yeah. Also, they're just more general than you know reactive UIs. Like you can use signals on the back end. You can use signals in a data layer. Like the internals of like Apollo could be rewritten in signals potentially. Um, and I think that that is a much more powerful primitive. It's like that tree of components is one use case, and it works really well for that. We know it works really well for that. But I'd love to see where else it can be applied, what other things it can be used with, because I think there's lots of use cases for this primitive now that we have like a kind of handle on how to do this sort of reactivity.
Yeah, one
Yeah.
example of that was in build systems. There's a lot of use of and development of kind of advanced signal algorithms for build systems that you do a minimal rebuild, which kind of has a lot in common with like a tree-based re-render. They're kind of a similar shape of problem, where you could change the make file, or you could change any of the source files, and you want to rebuild the minimal set of things. So it's it is kind of a fundamental algorithm. So I like Kristen's idea of signals as a monad, or another way to put it is like they're a thing or they're first class. So before, I think a lot of systems were trying to figure out the reactivity problem without making the signal itself a thing. And that led to certain, if you just kind of try to jump directly to the solution, you might miss the places where it's slightly incoherent or incorrect to treat things a certain way. So in reactivity, there's a thing that we call a glitch, which is where you're observing the state in this kind of partially updated, inconsistent way. And naive algorithms for implementing signals or for implementing reactivity naturally lead to this. if you're not lazy about when evaluation happens, if you try to evaluate something as soon as the state changes, then you're likely to see the state in a half updated way. And that can
Right.
lead to user facing issues. This is one of the things that React solved right from the beginning, because you change the state and then you render from the top. So eliminating glitches was really important, and thinking of signals as a thing or as a monad allowed people to just come up with the correct algorithm for, okay, how do we actually evaluate this graph in the right order such that everything is accurate. And this is also one of the properties why it makes sense for signals to be built into the language, because it is an inherent kind of basic, well-defined thing. It's not just a fad. People sometimes say, well, yeah, you're getting a new framework every week, so why should we standardize signals when, next week you'll be saying you want to standardize, I don't know, monads. And that's the thing. It's doing this common basic, lazy graph algorithm, lazy graph execution algorithm.
Incredible. Let's talk a little bit about auto tracking. You mentioned this term a few times. What is auto tracking? Is it more of an engine concern that users of JavaScript don't have to concern themselves with? Is it just the way to keep track of computeds in memory, or is there more to it?
It's a little bit more to that. It's the way to determine what signals are dependencies of a computed, right?
Right.
So auto tracking, like the alternative to auto tracking is that you either explicitly state what dependencies are. Imagine like use memo, where you kind of have to have like a dependencies array, right? Or you pass in kind of like a getter function, and every time you access a value, you use that getter function. And then that is what is kind of tracking things. I believe that Jotai is kind of like this, which is like same author as Zoostand. The benefit of that one is it is more dynamic. The dependency array is not dynamic at all, really. But the drawback is that you kind of don't have this nice property that we have with auto tracking right now, where you can take a function that was written without signals in mind at all. You can go and look at, okay, here are the few places where it consumes some state. I'm going to mark those state as signal.state. And then you can just put that function into a computed, and then it works. Because what auto tracking is doing is it's basically creating a like a scope, if you will, while the computed is executing, and any value that is consumed directly within that scope is added as a dependency. So just anytime you access a signal or another computed, and the scope kind of gets nested, right? So that other computed will then consume everything it consumes and expose itself to the parent computed.
So one thing that people talk about with async await and promises is the function coloring problem, that if you have an async function, suddenly everything that needs to call it is async. And auto tracking solves this exact problem with respect to signals. So when you have a function that might read a signal internally, it's just a normal function. It returns normal JavaScript values. It takes normal JavaScript values as arguments. It might read that state internally, and even though that might be nested deep in a call stack, the place that's consuming it, which might be a computed, or it might be like directly the JSX property of a solid element, in which case it'll be inside of an effect, then, or like ultimately inside of an effect, then you don't need to pass up and down the call stack what the dependencies are. You don't need to state what they are. The programmer does have to understand that it is significant when they read something. So that is sort of part of the programming model. Ideally, the programmers aren't really thinking operationally all the time about what triggers re-rendering, but it kind of ends up happening sometimes. Even back to what Kristen was saying before about how she ended up having to think in terms of the tree of like what triggered this thing to re-render. Like that's not supposed to be the way you're thinking about either React or signal-based frameworks. You're supposed to just be thinking this is a pure function. It's just going to calculate it. But in the end, there end up being these leaks in the abstraction because maybe you need a ref to do something imperative to the HTML element. In Bloomberg, I work for Bloomberg, and we have in our UI some complicated data layers or charts or worksheets that tables that you really don't want to just end up accidentally recreating from scratch. A subscription to a data feed. You want to be able to reason about when those are created. So that's sort of where the functional model breaks down a little bit, and where it becomes helpful to keep the operational model in mind. And that's what auto tracking gets to. So programmers end up having to understand, having to be able to reason about what the dependency graph looks like and understand when edges get added, because they end up wanting to know when something gets invalidated and rerun. And that's somehow different. I mean, that's somehow the same between React and signal-based models, even though the algorithms are different and the times when they're invalidated are, unfortunately a little bit different.
Yeah.
Right. But for the developer working with language level signals, do I understand correctly that it's all implicit? Meaning if I have a computed and it relies on some state signal that I've created somewhere else, I don't have to consider like a dependency array or anything of that nature. Okay.
No. No, it's more that the ways that code sometimes needs to communicate with the external world,
Right.
the non-signal part of the world, right? Just like, React rendering code has to, there's kind of sometimes a little bit of interrupt that you need to do there. And in order to do that, you do need to understand these rules, right?
Yeah.
And sometimes that means you end up having to follow that chain down. I find that in signals, that is much less common. I've also been working on like trying to come up with abstractions that make it even less common, and that's kind of where we've been in this discussion around like async, relays, which is kind of a concept that I've introduced into the discussion around the proposal, and like subscriptions, that sort of thing. So yeah, that's something we could talk about as well.
Yeah. How risky is it with computeds and auto tracking for a developer to create some very expensive computeds that rely on signals of maybe huge amounts of data or something like this. I realize the question is very crude, but anytime there's reactivity, like in the case of React, right? Like if you have a use effect that depends on an enormous JSON object or something, you will notice like small frame drops. Obviously, at the engine level, this can be like taken care of and optimized, etc. But is it is are there performance sort of gotchas that developers working with computeds should be aware of as the proposal moves more and more closer to like being accepted?
Well, there's kind of the opposite of a gotcha, which is that when you're working with signals, you kind of have an implicit use memo all over the place. You don't end up getting reevaluations triggered unless something changes. So it's slightly the it's slightly different. That this is the only reason why any of it works. If we didn't have that thing that checked that something had changed to trigger reevaluation, we would end up invalidating signals all the time. And so that makes it so that we don't end up, needing VDOM because you can just create an HTML element and it will notice that nothing changes. And so it just keeps using the HTML element. It doesn't need an extra data structure to compare. You can, of course, put too much logic in your computed or make your computed get invalidated too frequently if you read things that you don't actually need. And one way to solve that is to take a sub-computation of what you have and make that its own separate computed. So then it won't So then if the output of that changes, it won't trigger the surrounding things to change.
Fantastic. Let's talk a little. You mentioned part of this proposal is to make signals more universal. Like I feel like the vast majority of developers who are using signals today are using it in Angular or Svelte or Solid or one of these libraries and frameworks. But if it's a language level feature, JavaScript is a full stack language. Full stack meaning you can use it across the stack, right? Server, client, whatever. So this becomes very interesting because we can now have, as you mentioned earlier, Kristen, we have signals on the data layer. What are some interesting topics around this client server continuity with signals? Meaning, can I initialize a signal on, this is probably not possible, but I'm just dreaming here. Can I initialize a signal on the server side and somehow have that signal become reactive on the client side? Things like, mainly because this is now more universal. So I think of like resumability, for example, right? Like with Quick, client server handoff. This is sort of the direction I'm thinking. If it signals all the way down, then this should be in some way possible.
Quick itself actually implements that. They have signals, and their signals are resumable. So they serialize their dependency array and the initial value of the signal, and they can reason about what invalidates the signal without even hydrating it yet. And so a lot of the design of signals was that the signals standard proposal was in order to enable that. And as part of this, we have this introspection API, which actually is something that we have to revisit a little bit. But the motivation was definitely to be able to run things first on the server and then on the client. I mean, this comes back to one of the original criticisms of signals, that maybe for the first render, it's faster to do the React style, and then subsequent renders might be faster with signals. With certain older frameworks, that was definitely true. It did cost more to build this whole dependency graph. With quick style SSR, that certainly is not an issue. But I think even with just people getting better at implementing these data structures, it's already kind of solved even without SSR in practice.
Yeah. One thing also, a lot of early signals like implementations were really heavy in the sense that everything was memoized. Like there were tons and tons of computeds that were just at every single layer. Especially coming, like I was an Ember core team member for a while, and the applications that we were working on with Ember while we were exploring signals, they like almost every single derived value anywhere was a computed. So that was because previously it was like every single function call, basically, because previously like every single one of those needed to pass through explicit dependencies. So that was a ton of overhead that you just don't need in a modern signals app, because you don't need to memorize every single function. You only need to memorize like a handful. And then the overhead becomes a lot more comparable to something like React and VDOM solutions.
Ryan Carniato talks
Go ahead.
about this a lot in terms of having these functions with no arguments that you use interchangeably with signals. So, you could have different opinions on the ergonomics of that particular thing, but I think we all agree you don't have to use computeds for everything. I also want to mention that Kristen was largely responsible for bringing this modern pull-based reactivity to Ember, and she wrote this really great series of blog posts that you can find at bzuraq.com, bzuraq.com, that explains auto tracking, as the Ember community focused on calling it, which I think is a good focus, and explains the mechanics and certain pure pull-based algorithms actually for implementing it.
Fantastic.
I do have to. Oh, sorry. I do have to note that was definitely in tandem and with Yehuda Katz and Chris Selden, who both mentored me a ton on that. But yeah, all three of us basically, and the rest of the team were really, like, it was a fun time. We were really learning a lot of things all together, all at once, as we were building it, and it was really, really interesting.
I love your use of the term "fun" there. It's because I fully get it. I heard people say that React, with its current rendering model, will never be as fast despite the React compiler as a signals-based rendering model, mainly because of walking the tree. Meaning, even if everything's super memoized in React, you've still got to walk the entire component tree, and maybe it will yield the same value. So maybe it's a memoized component, maybe it's not. Is that true? I mean, it sounds very true, but I wanted to hear it sort of from the horses. I'm not calling you all horses, but
Uh, I don't know if that is true. It's at that point we're kind of getting into a level of theory that I think isn't as practical. Yeah, some React apps may at scale not be as efficient as some Signals apps, but the vice versa might also be true. Um, I think more so to me, the questions are how easy is it to write that app that is maximally efficient? Because I think that's a lot more common is that you are doing an anti-pattern or you are writing an app that is very efficient but very hard to understand, and so changing anything takes forever. Or you are writing an app that is easier to understand but very inefficient. Or it's both hard to understand and inefficient, which I'm sure many of us have had to deal with at some point in our careers. Um, the what I'm finding in React versus my time kind of like most recently was felt is it is harder to once things get to a certain level of complexity. Um, and Svelte, to be fair, like Svelte, I think 4 doesn't really have signals. It just has stores. Um, it and like local signals kind of with its like little let computed values and the dollar sign thing.
It's kind of more
Um,
like observables, right? The way that Svelte stores work.
yeah, so stores are well, stores aren't even like observables. They're just like dead simple like
do we mean runes?
subscribables. Which?
Do we mean runes? That I believe that's their term for signals and spelled
Oh, but that we're
runes.
talking about Svelte 4. That was introduced in
Yeah,
Svelte 5.
Ah, right, right.
yeah. Svelte stores were like super simple, and it's like this thing is just the engine, right? Like you have to provide everything else yourself, and that's you know great until it isn't. Also can get very complex, but at the very least, it was like pretty predictable how that interacted with the rendering layer. The thing I'm struggling with right now is like I said, I'm like layering stuff on top of React Router, and it's like, okay, how do I make sure this does not cause me to re-render the entire app? Um, and that seems like a question that could come up quite often. And if somebody
Yeah, it
has to
does.
really understand the full application or like huge chunks of it to know how to do that, that seems like not the best. It feels like it's really easy to accidentally step into that territory in React so far. And,
Yeah.
you know, that that's it's less easy with signals in my experience. Like I am more confident writing signals and knowing like, okay, I know this value is changing. I know how to hook it up to everything. And I know that it is not going to cause the world to re-render every single time I use it. Um, that's been
Awesome.
my own experience so far. And I say this is like I over the years I have built React things, but I have never built
Yeah.
like a significant React thing. So maybe I'll learn
Right.
more as time goes
Yeah.
on.
So
Yeah.
so
And that's it's
I agree with Kristen that the important thing is not like what can be the highest absolute performance, but what works out better in practice as a programming model. If signals were faster but then made it harder for people to get their job done, they probably wouldn't be the right thing for us to be standardizing. The only reason that we're looking at this is because we do have a number of successful frameworks that do implement these high level programming models that people can build bigger things in. And yeah, I don't know. Some experience with data layers and signals and making sure that they don't get reconstructed kind of matches the experience that Kristen is describing.
yeah. Fantastic. Thank you. Thank you for capturing the nuance there. I have two more questions about signals, and then we can move to some of the audience supplied questions. This question I'm about to ask is a continuation of our discussion on sort of this like client server continuity that Quick is implementing without signals, but that signals will enable from a language level, which is reacting to not signals scoped within the scope of a program, but instead external signals. For example, I have a client application and I want to say, hey, when this signal somewhere over there on the other across the network changes, then update here in my application. I can think of a very crude way to implement this type of behavior, especially given the Watcher API or the Effect API, right? But is this something that is being considered for standardization, or is it just no, we're giving you APIs, you wire this together yourself, sort of the way I'm imagining I would?
So, this is a problem that I am very much dialed into, and I think this is actually one of the hardest core problems of reactivity. It all comes down to async, right? Like it's always like these async
Yeah.
like things that make programming so hard. Um, but this is what the relay kind of proposal that I put out there is all about. And I think it really comes down to I've narrowed it down even further now. I think that there are two kinds of things you can do, two types of data sources that can be put into a graph that are asynchronous. There's call response, which is effectively a promise, and then there's subscriptions, where you can subscribe to some external data source. As long as you're subscribed, as long as you're watching that value, it should feed you updates, and then you can unsubscribe when you no longer need that value. And that's very similar to like the classic React use effect to set up a subscription and tear it down type of thing. The difference with the relays idea, and maybe potentially it's just ends up being like async computed and subscription computed or something, is that that entire process is consumed, like encapsulated in a single node, if you will. It is a signal that exposes some state like it's just any other signal. So you're not setting up an effect when you render your component. You're just consuming this signal like it is static state.
Right.
And in doing so, that will either start this request that's, it's going to do a fetch and return that data, or it'll set up the subscription to that asynchronous data source. So you can imagine how you would do this with, like your example of wanting to subscribe to a signal on the server. On the server, you would have a signal. It would be feeding into maybe a watcher. That watcher would publish the event to a WebSocket. That WebSocket would come into the client, and on the client, you would have a relay that is listening to that because you're subscribed to it, because you're watching it, wanting to send it into the DOM. It would see that event. It would expose that into the state of the graph, and then it would trigger an update.
How would it expose it into the state of the graph?
So a relay is effectively like just like any other signal. So you're just doing signal.get. The main difference is that relays have kind of an internal life cycle. So they have like a start and or a subscribe and an unsubscribe or something like that. I forget the exact API I designed, and this is like very much like
there's a really good blog post on Kristen's blog. It's like the second one, called On Signal Relays, that goes through the details. And
awesome. Yeah, we'll put a link to the show notes.
And in particular, all this can be expressed with our current Signal API. We have this thing called watchers, and watchers, when you watch a signal, so a watcher is sort of like a set of signals that are being watched that trigger this shared callback. And each signal, whether it's a state or computed, can have this callback that's passed into the options object, which is watched or unwatched. So like in the past tense with ed at the end. And what those do is they get called when the signal becomes live, in the sense that it is a dependency of something that's contained in a watcher, or it's directly contained in a watcher. So what you can do with that is basically when something is read in an effect. So for example, if you put it in your JSX, then it will in the watch callback make the subscription, and in the unwatch callback remove the subscription or cancel the or like cancel the abort signal if it's like a promise. So I think that's this kind of core primitive that we made because we were thinking about different approaches, relays, but also async computeds being kind of a built-in construct. And we reasoned ultimately, and this was a big collaboration with people working on Solid.js, who, especially Milo M and Shay Lewis, who had these ideas about how we can have a dependency graph of async signals, and ultimately it boiled down to the same problem of needing to be able to react to whether something is being watched or not. Because ultimately, if it doesn't lead to an effect, it's not really appropriate to maintain a subscription. It needs to be something that you could just sort of read instantaneously and synchronously. So it just can't work for those asynchronous things.
Yeah. This is like a big part of the reason why the watcher exists as a separate concept from computeds. You could imagine a world where you just have computeds and it's just like memoized functions, and maybe we have some way to notify things. But if we don't have this thing that this concept of a watcher where it basically says, okay, now this part of the graph is watched and everything on it starts its subscriptions, becomes live in a sense. There's not really a way to handle the subscription part of this. Like you could kind of do it with the async part, right? Of like making a fetch request. But if you don't do that with subscriptions, there's no way to clean up those resources later on. There's no way to tell your program like, hey, I don't need that subscription anymore. And now they'll just keep building up. You'll start having like, tons of resources being used that you're no longer using, and it is a mess. So
yeah. And for async, you want it with canceled fetches as well. You
that's
hopefully
why I said
want
it's
to, but maybe you can get away with it because it's not that bad.
It's like kind of it would work on the front end. It wouldn't really work in Node now because you can't have dangling promises anymore. It's like kind of works. It's much better with a watcher that tells you like, oh, you don't need that promise anymore. Cancel it. Don't send that fetch request.
Yeah, so we have a combination of auto tracking. So when you have a computed, the dependencies are maintained implicitly and you subscribe and unsubscribe automatically just based on what's used. And watchers where you explicitly put things into the set and take things out of the set. And when it comes to the framework, sometimes in a lot of frameworks, you don't actually have to dispose of your effects because they're disposed automatically when the component is removed from the tree, when it's destroyed, when it kind of is no longer in the rendering. And that's based on this kind of ownership graph. And we don't model the ownership graph in signals. We leave that to the framework, even though we talked about modeling it. Like it would be really cool if we had it, but there are just a lot of differences between the way different frameworks do it. So it seems slightly premature to try to land on one thing.
The only part where there's kind of like an ownership graph is where so every time a computed reruns, it could consume different state or different computeds, right? And that is dynamic. So if you rerun a computed and a watched, subcomputed signal relay is no longer part of the dependencies and no longer part of anyone's dependencies, now we unsubscribe. And if you consume on that second, rerun a relay that will trigger a subscription, now we subscribe. So that it's not just like the immediate dependencies of the watchers, it's all of their dependencies as well that are part of this graph. But like the dependencies between watchers or anything like that is framework land at that point.
Yeah,
and
we had so many funny conversations where we were debating what we mean by owner, what the data dependency like Kristen is talking about, or like the disposal like component tree. Anyway, I I shouldn't have used the word in the first place, because we kind of tried to ban it in our internal conversations. But yeah.
Noted.
So
Yeah, I'm glad I asked such a question that is such a topic of discussion right now with this. I had another question, specifically just zeroing in on this a little bit, because can in this, like when you do new signal dot state or signal dot computer or dot state, right, and you create a new stateful signal, and you mentioned, Daniel, that you can have sort of as a second argument configuration options for your signal, like this watch on unwatch callback, meaning when it gets watched, do this, and when it gets unwatched, do that. Set up the subscription, clean up the subscription, etc. Can signals self-reference in their watched and unwatched callbacks? Meaning, like set the signal to the new value when something changes after, like, so what I'm thinking of is you instantiate a new signal, and in the watched callback you set up a subscription, and when the subscription sends you new data, you update the value of the signal there. This is that, am I thinking of watched correctly to update the value of a signal?
So I think this is one of the places where we noticed an inconsistency after we published the initial version. There's this person that goes by the GitHub username of Profile, who has been very helpful, Alistair, who's been very helpful in letting us catch these things. So there are three places where we actually prohibit you from reading or writing signals. One of them is in the notify callback for a watcher, like just the callback that gets called for the watcher. We don't let you read or write signals there, because you're probably going to do something bad. You
Dangerous,
shouldn't
yeah.
you shouldn't really be synchronously reacting to signals. I mean, sometimes you do want an effect that will run before you yield to the event loop or even to the microtask loop. But if you do it really in the middle of when everything's happening, it leads to all kinds of inconsistencies. And this is something that was discovered independently by basically every framework. You really want to do your updates afterwards. And at the timing for afterwards, there are lots of different timings that you need for different, cases. I mean, effect and layout effect are two of them, but sometimes you need it to be even sooner. But right in the middle is probably not a good idea. And similarly for watched, with an ed at the end and unwatched, this contributor noticed that it would be inconsistent to, in certain cases, to allow reads or writes from signals there. So we're kind of banning it to happen synchronously there. I mean, the use cases are a lot about doing these external things that might be async. So I don't think it'll really be very missed. And overall, you can work around the asynchronous restriction. You can get these effects to happen synchronously if, before you yield to the event loop, you just sort of poll to see if anything happened. So like in your watcher callback, you could write to a list of things that had their watcher callback called, and then before yielding to the event loop, check that list and see whether there's any action to take.
Right. For the watched and unwatched API though, those can, I don't know about the timing part of it, but the idea is that you set up a subscription in there, and that subscription will write to that value. And effectively, they're kind of like a low-level version of like a way to implement something like a relay or a async computed or a subscribe computed, unsubscribe computed.
Sort of interrupt. What does write that value mean?
So the way I think about it is effectively you have two different graphs. One is the graph of like some external state that you then want to kind of, almost like a watcher, take the leaf node of that like final computed value of it, and then feed it into another graph at points. And that's kind of the idea that I have with relays, is like a relay is that communication bridge. That's the name. It's like it's relaying from one graph to another graph.
Got it.
So the implementation of a relay is, like a state computed or a state signal, or multiple state signals potentially. And you are like taking through some external process, you're taking the new values and then writing them to that state. But externally, you act as though that is just like its own self-contained thing, and nothing else has the information there. Okay, to make this concrete, this is a very much like libraries like React Query or SWC, right? Where you have a fetch request, and rather than having like a promise that's being exposed, and then you're like, kind of like, setting is loading and whatnot yourself, you are calling like use query and with a URL or query of some kind, and you get back this like result, which starts off as like null, is loading, which starts off as like false
True.
or true or whatever, and so on and so forth. That is a perfect example of the type of API you would expose with a relay. The relay would return the initial state to you of like, is loading true, is error false, whatever, data. And then it would, at the same time, kick off that request. And when that request comes back, it would update that state internally. And that would tell everything else like, hey, that request returned. And now you should recompute.
Yeah.
Right.
So in particular, two short things. One, whenever Kristen talks about relays, just remember everything that you could do with relays, you can do with the Watcher API. Relays are just a very thin abstraction over it. So check out the Watcher API today, and also the relays a post if you're interested. But you could test all these ideas with the signal polyfill that we have published. The other thing, just to kind of summarize, although there's a block on synchronously reading or writing signals from the watcher notify callback, as well as the watched and unwatched callbacks, the entire intention is that those are going to trigger you to read or write those things. You just have to do it after that callback returns. You have to do it at some other time.
Okay. What does the watched and unwatched callback return?
Oh, the return value that you give is ignored.
Okay. So it's okay. Yeah, that makes sense. Final few questions about this. How does one? So in solid.js, you read a signal by calling a function. You write a signal. You get a setter. You get a tuple. You get a getter and a setter. With Quick, it's different slightly, right? You have this dot value property on your signal, and you read it that way. Read dot value, you set dot value, and that's because most of these use proxies, and proxies allow you to override the get set behavior of objects. How does language level signals differ from? Do they differ from this at all? Like how do developers read and write signals with just the language level signal features?
It's just a method, .get and .set currently.
Nice.
It's pretty similar to kind of like the .value one in the end, right? Because you can have a, I think Preact also does it that way. You're calling functions effectively, right? So there's not really like a performance difference between the two. It's just more of an ergonomics thing, and maybe being able to kind of more easily like subclass that and potentially pass in parameters. Maybe you make like a computed signal that can receive arguments as well as read other signals and return values, and that is something you could expose with this API.
So to develop the decision to choose the .get and .set APIs, we actually got together a number of different framework authors and maintainers to discuss what signals should look like, and we had debates over the course of like 6 months before publishing the signals proposal. And this was one of those debates. Of course, we debated about like every little inch of it. So there are lots of things that use this, like you said, the tuple design where you have like the getter and the setter, and there's also the dot value one. Nobody uses dot get and dot set. It's way too ugly.
Yeah.
And to do value, you don't even need the efficiency risk of proxies, because you just need the define property call. You just need to make getters and setters. So it doesn't even need ES6, the dot value thing. So the reason that we went with dot get and dot set was because all the frameworks found that they would either want to wrap or subclass signals anyway. So there is kind of an argument for separating the dot get and dot set. It's kind of nice to have them be separate like capabilities. That when you're passing around the ability to read a signal, you don't also want to pass around the ability to write it all the time. And conversely, the dot value thing is kind of nicer looking. The idea was that frameworks that want to use dot value are probably going to subclass signals. And so the subclass can add that getter setter for the dot value property. And frameworks that are going to expose the two different objects, they're already going to want to wrap it. And so if we provided a pre-split out version, they would have to wrap each one anyway. So it wouldn't really save them any particular work. That's at least our theory behind it. And I don't know, choosing an API that everyone can kind of equally hate maybe could push people towards using frameworks, which is what we want.
I have so much respect for the work that y'all do, because you can't make everyone happy, and you've got such huge decisions to make, and you do this in collaboration with, like you mentioned, library authors. I have to assume Carniato was a part of this discussion, and probably Mishko from Quick, and that's so cool. So you really weigh the pros and cons, peel apart every single detail, and argue for a long time. Well, maybe argue is a strong word, but disagree and discuss for a long time until you arrive at the best possible outcome for the widest array of developers, because there's no breaking changes. And once you make a decision, it better be as close as possible to the right one. So that is just, I can't appreciate enough like the magnitude of such decisions that you'll make. And I so appreciate that you take them so seriously. I could talk about this like for honestly like 3 more hours, but we don't have the time. So let's quickly pivot and talk about some questions from the audience. They've been nice enough to ask some, which is very nice. Which, you know, I just need to like also stop and just marvel at the fact that this is my life. Like I get to talk to y'all who make this language that I write every day, and who the language that gives literal life to thousands of people, hundreds of thousands worldwide, right? Who like make a living off this stuff. It's bananas. So I don't take the time lightly, and I'm so thankful for all of your insights and contributions so far, as I'm sure the listeners are. Speaking of the listeners, the first question from listeners, they really want to know the status of the type annotations proposal, which, if I understand correctly, is the proposal that brings TypeScript style type annotations, but as JavaScript, is this different from types as comments, where the engine just ignores type annotations, therefore helping interop with TypeScript, but still not really adding any type safety? What's the status of that?
Yeah, I've been working on the type annotations proposal a bit over the years. So type annotations is just a new renamed types as comments. It's the principle is the same, that types are erased. Types don't have runtime meaning. And that's because TypeScript has really demonstrated in practice that a weak type system with really complicated types is best for just what JavaScript is and the way people use it in rather complicated ways. It's just a really good model. And there could be some assertions at runtime, but it would be a different language from, you know, what you use every day for types.
Yeah.
There are a number of things that are complicated about type annotations. For one, web browsers have expressed skepticism about implementing a feature which wouldn't have behavior at runtime. I mean, they do implement comments today, and they added the hashbang comment feature, but it's kind of more complicated to parse types. Another thing is it's kind of complicated to design a syntax for type annotations which is stable over time and which matches TypeScript pretty much, but also isn't necessarily all of TypeScript's grammar, because there's some kind of complexities there. Maybe we should add it in a way that includes most of TypeScript's grammar, but it's also not clear what we should do when TypeScript adds something new. We have to think through those questions. At the same time, one of the core things in type annotations was it only adds things for the types that act as comments that are erased. So if you have TypeScript code which uses namespaces, enums, or constructor parameter properties to like initialize some properties of the object by writing like public x in the constructor arguments, those don't work with types as comments or with type annotations. And that's because it's only the things that are erased, only the things that are comments. And actually, Node.js is moving in a similar direction. So Node.js has a new flag. Can't remember what it's called, experimental TypeScript something.
Yeah, I've seen this.
And that's very exciting. And it focuses on this analogous subset of TypeScript. It doesn't face the challenges that I mentioned about choosing the right subset of TypeScript grammar that's good enough to be stable. It uses the current TypeScript grammar, but that grammar is generally developed in a way that's backwards compatible, so it's fine. But what it does by subsetting the features that you could think of as maybe modern TypeScript, the features that are just the comments, is really ensure the strong stability of it. You don't want to publish something to npm and then people are using different versions of Node and it works differently. And arguably that's not really a risk with namespace and enum because they have been very stable over time. So it's not really a practical risk. It may be more of a theoretical risk. But still it's not exactly necessary to use some of these features. With namespace, you can use either an object literal or a JavaScript module, for example. So at Bloomberg, we're actually developing a library which we're planning on open sourcing by the time this podcast is published. That's called TS blank space. And what it does is, one of the annoying things about TypeScript is that you have to use source maps. And on the client, maybe you already are definitely going to use the source map because you need to minify and bundle your code. But for Node, it can be a little annoying to configure sometimes, especially if it's just for TypeScript. It can make debugging hard if you don't end up having it configured correctly. So what TS blank space does is it changes all the types into white space, which you can do if you're sticking to the subset of features that are just comments. So TS blank space is a really small package that's basically just the using the TypeScript parser. So no need to rewrite the TypeScript parser, and then just outputs the same code just with the types replaced by blank spaces. So this allows it to be really fast, and it does restrict you to using this kind of modern TypeScript subset, but I think that's a reasonable subset to use, and I think it's a way to stay aligned with the JavaScript language to really yield true to the promise that the TypeScript is JavaScript plus types, and actually it has pretty good performance also. So I'm excited about that sort of approach catching on, and in some way that's part of the important part of type annotations or types as comments to really stabilize the ecosystem and focus on the type part.
But you say stabilize the ecosystem. How is it unstable? Like I'm not sure I and many of the listeners see the exact problem it solves, right? Because like TypeScript compiles away. So the final artifact that you publish, the JavaScript artifact, doesn't have white space, it doesn't have comments, it has nothing. It's just JavaScript.
Yeah, but you really want to ship your source to npm and then let the consumer bundle and minimize it. So I think TypeScript is already stable enough that you already could do that, but the ecosystem doesn't kind of have those expectations all built into it. I think it's getting there. It took a while for people to accept shipping ES6 in npm, and now people get it and they do ship normal JavaScript. But with the types, stripping away the types makes debugging harder. And so this is something that can be addressed just at the tools level by getting everyone to put their source maps into their npm packages, but then that increases their weight in a way that doesn't help at runtime. So, there isn't a way to delay to make the installation of the source maps lazy, like on the web they're lazy, which arguably is something that could be built in and added at some level or other. And we just have to figure out this tooling problem at some level or other. There are lots of different possible levels, but I think making TypeScript just work with Node is something that's been requested really tons and tons of times. And Node has its stability guarantees. It has an LTS process. They don't want maintainers of packages to have to make a major breaking change because something in TypeScript changed. And in practice, TypeScript has been extremely stable. But also the formal stability guarantees are slightly weaker, which is reasonable. I mean, most of the time, if your code breaks due to a TypeScript version upgrade, that's because TypeScript found a bug in your code, and now you get to fix the bug, or add enough as any's until the error goes away, or enough annotations to tell TypeScript to go away. And that's usually a good thing. So none of those really affect what you need, though, when you're just trying to run a package that's a dependency that you got in npm. You don't really care about detecting type errors within those dependencies. You just want to get the code to run. So you just want to strip away the types. So having this become a more established concept in the ecosystem, I think it will enable greater adoption of TypeScript and just give all these different actors the confidence to just use TypeScript in more of those cases.
Yeah, I love that. I naively thought that the intended end benefactor of such a proposal would be the people consuming websites. But I completely missed the whole ecosystem of no, there's people who install these packages who need that information but don't want to update their entire build pipeline to then handle TypeScript only dependencies. And this all makes so much sense now. And I'm sure it's not just me, the listeners as well. That's the only audience question we have time for, which is such a shame. But it just means we maybe need to do this again. Listen, Kristen, Daniel, thank you so much, both of y'all. Some of the smartest people building I think maybe the most popular programming language in the world. I might get in trouble for saying that, but so widely used, so many applications. We spent so much time talking about one proposal, one feature, signals, as a long-standing evolution to the problem of building reactive stateful applications in a scalable and healthy way. On behalf of myself and all the listeners, I cannot begin to thank you enough for how much value you've added. But I hope it suffices to just say thank you so much.
Thank you. Really appreciate it.
Thanks so much for having us here. You've been a great interview or discussion.
Thanks.
I would love to continue this.
Let's do it again.
All right,
Anytime.
Take care. Thank you. Thank you for joining my discussion with TC39's Daniel Ehrenberg and Kristen Maevyn. I hope from this discussion you understand signals deeper and better than you ever have. I hope you understand fine-grained reactivity that they enable, and also the reactivity that they may enable across the entire JavaScript stack. If you're learning from and or enjoying this content, then a great way to support it with really low or no effort or cost is to like the video on YouTube if you're watching it on YouTube, and subscribe to the channel and share it with your friends on social media. If you're listening on Apple or Spotify, then if you'd leave up to a 5-star review, depending on what you think the podcast deserves, that would also be a great help and a support to the podcast with really no cost or effort. Of course, if you want to share any of this on social media, break it down into clips, show it to your friends, all of that would be a huge help. I do this for you, and I'm so thankful that you're here. Thank you for being a part of the podcast. Thank you for your participation in our discussions, and most importantly, thank you for your interest in engineering.